Okay, sometimes we have a set of equations and we don't want to have to graph them to find out where these two lines intersect. These are clearly linear equations. So we have to do something different. In this case, what we can do is we can subtract one equation from the other and eliminate one variable to solve for the x, and then put back in to solve for y. Let's take a look at how we do this. I'm going to rewrite this equation as negative 5x plus y equals 3. Right? This is so that I get my y's right one below the other. Now, because they both have a coefficient of 1, I can subtract one equation from the other. So I'm going to subtract negative 5x plus y equals 3 from 3x plus y equals 15. I'm going to move this out of the way so that it's easy for us to see. Now, I've got 3x minus a negative 5. That's the same as plus 5. So I get 8x, and I have y minus y equals 0. And then I have 15 minus 3 equals 12. Right? So now I have this 8x. I want to divide 8 on both sides. And I get x is equal to 12/8, which is 1.5. Now I can take this number and put it back into one or the other equation. It doesn't really matter which one we do. So let's put it into this one. So now I have 3 times 1.5 plus y equals 15. Well, 1.5 times 3 is 4.5. So I'm going to subtract 4.5 from both sides. All right? So now I've got y equals 15 minus 4.5 is 10.5. Let's see if that works. We're going to put both of the numbers in to the second equation and see what it says. So I've got negative 5 times 1.5 plus 10.5 equals 3. Let's see if that works. So 1.5 times 5 is 7.5. So I have negative 7.5 plus 10.5 equals 3. Well, 10.5 minus 7.5 is 3. So 3 equals 3. It works. You can add and subtract one equation from another to eliminate a variable and solve for the numbers. So in this case, the point where these two lines intersect are at 1.5, comma 10.5.